Hello everyone. Am I audible? Am I audible? Am I audible? Hello everyone. I welcome you all on this amazing platform of Physics Wala Vidyapit, Chennai. Students, myself, Atul Kumar, and your chemistry mentor. First of all, I wish you all the best for your upcoming JEE Mains 2025. Now, students, let's talk about today's session. So today we are going to solve the mystery of chemistry. What we are going to do in this particular session? So this session we will thoroughly dedicate to the previously years asked questions, mainly all the typical PYQs which have been asked recently in the last 5 to 6 years. So without wasting any further time, let's start our today's discussion. So in chemistry, mainly we'll be starting with physical chemistry. We'll be discussing the PYQs and all the important questions of these chapters. And then once we are done with the physical chemistry part, we'll move to organic chemistry. So this particular session will not only help the aspirants writing JEE mains or JEE advanced this year, but even for class 11th students who are moving to class 12th and going to write your JEE in the next year. So let's start our session. So we are going to start our today's session with atomic structure. And here is the first question there on the screen. The question says, for a hypothetical hydrogen-like atom, the potential energy of a system is given as UR equals to minus KE square upon RQ. So potential energy as a function of radius is given, where R is the distance between the two particles. If Bohr's model of quantization of angular momentum is applicable, then calculate the velocity of the particle. Okay, students. So this particular question is taken from Bohr's model, but can we apply the direct formula here? The answer is big no. Why? Because we are having a hypothetical hydrogen-like species, right? So let's try to understand this question. I am taking an atom, a nucleus, right? And here, what they have given potential energy as a function of radius, and potential energy is minus P E square upon R cube, right? So this is electrostatic potential energy. If potential energy is given, can we calculate the magnitude of electrostatic force? Yes. This electrostatic force is conservative in nature, so I can calculate the magnitude. I can write mod, and this electric force will be equals to minus of du by dr, although this minus won't be that valid here, so I can directly write this mod du by dr. Although whenever I am writing this conservative force, this conservative force is always equals to minus dou u by dou r. So now we can differentiate this electrostatic potential energy and we can get the value of electrostatic force of attraction operating between the protons or the nucleus, which I can say is having a charge of ZE, and the electron, right? So let's try to differentiate it. Minus of d by dou r of e square upon r cube. So this r to the power minus 3, this minus 3 will go this side. So this is minus 3, and minus of minus I can say directly, I can write it as plus e square upon r k power 4. So now this is my electrostatic force of attraction, and this electrostatic force of attraction will provide the necessary centripetal force, right? I say, I write the equation number 1, and this equation 1 will be k square 3k square upon 3k square upon r to the power 4 equals to mv square by r, right? This is my equation number 1. Now, if we look at this particular question, the question says Bohr's model of quantization of angular momentum is valid. So, if quantization of angular momentum is valid, and this angular momentum is nothing but moment of momentum, so it is mv dot r or mv cross r I can write, that is equals to nh by 2 pi. This is my equation number 2. Now, with the help of these two equations, we can calculate the magnitude of velocity, right? Can you do it? Let's try to do it. mv equals mv r equals to nh by 2 pi, so I can write this r as nh upon 2 pi dot mv, right? And here 1 r will cancel out, so I will have 3k square upon r cube, that is equals to mv square. Now here rq is there, so if I calculate the value of rq from here, I can put it there, right? So let us try to do it. So this r is nh by 2 pi mb, so rq will go as n cube h cube upon 8 pi cube m v cube, right? Let us assume it as equation number 3. Now we need to substitute this value of rq in equation number 1. Let us try to do it. So it's 3 k e square upon rq value is n cube h cube upon 8 pi cube mq vq mq vq, that is equals to m v square, right? That's it. Perfect. This will go up, so I will have 24 pi cube into k into e square into mq, and 1m will get cancelled, so I will have m square into v. This v will go up and this one will be down, so n cube h cube, right? That's equals to 1. So from here, this v, I can calculate the magnitude of velocity, which will be nothing but n cube h cube upon 24 pi cube k e square m square. Let's have a look at the options. V equals to n cube h cube 24 k e square pi cube m square. I hope this one was our answer also. M square. Perfect. So if we look at this particular question, the correct answer is C. The correct key is C. How many of you could solve it? Anyone who could solve it? So here the key concept was, directly if hypothetical hydrogen like species is given, we cannot apply the formula directly. First, we need to calculate the magnitude of electrostatic force of attraction, counterbalance it by the necessary centripetal force, equation 1. And the second they have already provided, that was the quantization of angular momentum. And this if angular momentum is quantized, so this mvr is an integral multiple of h by 2 pi. Using these two equations, we could easily get the magnitude of velocity, right? Shall we move ahead? Let's move ahead. Okay, now moving to the question number 2, and if we look at this particular question, it was asked in JEE Mains 2021 February attempt. Let's have a look at the question. According to Bohr's atomic theory, kinetic energy of electron is directly proportional to z square upon square. Option 2, the product of velocity of electron and principal quantum number is directly proportional to z square. Third one, frequency of revolution of electron in orbit is directly proportional to zq upon n cube. And the fourth one is Coulombic force of attraction on the electron is directly proportional to zq upon e power 4. Okay, if we look at this particular question, directly taken from Bohr's model, formula based question, the key concept is you need to remember each and every formula, whether it is radius of electron in the nth orbit, velocity of electron in the nth orbit, total energy, kinetic energy, potential energy of electron in the nth orbit, then frequency, and the last one, the Coulombic force of attraction. So, shall we try it? How many of you can do it? Please do it ASAP. So these are directly class 11th question taken from the chapter atomic structure. Can you solve it? Which one is the correct key? Shall I start? Okay. Kinetic energy of electron in the nth orbit. Magnitude of kinetic energy of electron in nth orbit is same as magnitude of total energy. The sign difference is there, but magnitude wise it's same, and that's in the nth orbit. N represent the orbit number, and that's equals to minus 13 points. If I am writing magnitude, so let me write directly the magnitude. 13.6 into z square upon n square electron volt per atom. Right? First option says kinetic energy is directly proportional to z square upon n square. This one is my constant. So can I say this Ke is directly proportional to z square upon n square? So option A is definitely correct. Let's move to option number B. Velocity multiplied by principal quantum number. So what they want from second option is the product of Vn into n. Velocity of electron in the nth orbit multiplied by the principal quantum number. What is the velocity of electron in nth orbit? It's 2.1 into 10 to the power 6, right, into z by n. Let me write it as constant k or k dash into z by n meter per second. So this is the velocity of electron in nth orbit. Now I need to calculate the product of Vn and n. So Vn multiplied by n will be k dash into z by n into n. This n and l will cancel out each other. So these two products is directly proportional to z. What does the option say? Option say it's directly proportional to z square. So this particular option is wrong. Frequency of revolution of electron in nth orbit. Once again, a very typical option, but important one. May be asked even in any of the attempt this year also. Frequency of electron. What do we mean by the term frequency of electron in nth orbit? First of all, tell me what do we mean by the term time period? Time period of revolution. It's basically the number of, if I talk about the time period, it's nothing but the time taken to complete one revolution. If I talk frequency, in unit time or in unit second, how many revolutions does this electron has made, right? So if I talk about the frequency of electron in nth orbit, that is option number third, Fn, can I write it as Fn will be equals to Pn upon 2 pi Rn. Velocity of electron in nth orbit divided by 2 pi Rn. And what is Rn? Radius of electron in nth orbit. Pi is anyhow a constant, so I can ignore it. Pn some k dash into z by n divided by 2 pi some constant into again some constant k double dash into n square by z, right? Now this z will go up. So the frequency of electron in nth orbit will be directly proportional to z square upon n cube. A very important result, please do remember it. And here it's zq upon nq. So option third is also wrong. If I move to option number 4, let's move ahead here. Coulombic force of attraction on the electron. Coulombic force of attraction on the electron. Satyam, please go to the option number D. Without solving each of the options, we cannot comment on the answer. Coulombic force of attraction on the electron. What is Coulombic force of attraction? Coulombic force of attraction is K Q1 Q2 upon R square. What is Q1? The magnitude of charge possessed by the nucleus, right? And if Z is the atomic number, then I can say the magnitude of charge will be ZE. What is Q2? Q2 is the magnitude of charge possessed by electron. So its force of attraction will be equal to K ZE square upon R square. And now if I look at this R is nothing but n square by z, and that too whole square. So k z square upon r square, this will go as n4 and this will go as z square, so this z square will go up. So Coulombic force of attraction will be directly proportional to zq upon n raised to the power O. An important one. So through this particular question, we were able to calculate or summarize all the important parameter and formula related to Bohr's atomic model. Coulombic force of attraction is directly proportional to zq upon n ki power 4, and this is what we have derived. So option D is also correct, option A is also correct, and A is the right answer. Great, good. How many of you could do it? Satyam could do it. Puspak, right? Frequency is 1 by T. A and D statement is right. Perfect. Rudra, 11 JB1. Okay. Shall we move ahead? Shall we move ahead? Okay. Let's ahead. If I look at this particular question, again from Bohr's model only, but here now it is related to energy, related to electronic transition. Electron is there in the nth orbit, it is switching to n plus 1th orbit, and then we need to calculate the value of n. A typical question even can be asked in modern physics. So this particular chapter is really important. It will not only help you in chemistry section, but also help you in physics segment. So if I talk about the weightage of this particular chapter, a minimum of 1 question from atomic structure and 1 or 2 questions from modern physics. Sum total of 3 questions. The electron in nth orbit of Li2 plus is excited to n plus 1 orbit using the radiation of energy 1.47 into 10 raised to the power minus 17 joules. The value of n is. Can you calculate it? Can you calculate it? Can you do it? Everyone? Can you do it? Okay. So let's start. Here, electron is initially present in the nth orbit. Now it's switching to n plus 1th orbit, and for this we are providing a necessary energy of delta E is the energy required, which we are providing, and it is how much? 1.47 into 10 raised to the power minus 17 joules, right? What will be the energy of electron in the nth orbit? The energy of electron in any orbit is given as minus 13.6 into z square upon n square electron volt. Remember the term unit. Here the energy I am writing is in terms of electron volt, and the energy which they are providing is there in terms of joules. And here the energy will be in the n plus 1th orbit will be minus 13.6 into z square upon n plus 1 square. Suppose it is E1, it is E2. So what is the energy difference? Del E equals to E2 minus E1, right? It is nothing but E2 minus E1, which is the required energy which we are providing, right? So this energy will be 13.6. I am going to write it directly now. This minus and minus will come as plus. So 1 upon n square minus 1 upon n plus 1 whole square electron volt per atom. This delta E is equals to how much? 13.6 into z square into 1 upon n square minus 1 upon n plus 1 whole square into 1.6 into 10 raised to the power minus 19 joules. Now I have converted this energy in terms of joules, and this delta E value they have already given, and that was 1.47 into 10 raised to the power 1.47 into 10 raised to the power minus 17, right? Now can we equate it? Yes. So it's 1.47 into 10 raised to the power minus 17 equals to this one into z square, and z square value is 3 square, so it is 9, right? So it is 13.6 into 1.6, somewhere around 21, 2.1, right? So I can write it as 2.1 into 10 raised to the power minus 18 into 9 into 1 upon n square minus 1 upon n plus 1 whole square. And this 2.1 into 9, again it will go somewhere around 18.9, so 1.9 something I can take, and then it will be in terms of 10 raised to the power minus 17, so it is 1.47 upon 1.9. Second data I am leaving it, right? And that's equals to 1 upon n square minus 1 upon n plus 1 whole square. One important point. Now, whenever we solve it, always remember this n will be having a integral value. This n will be always be an integer. 0.46, 1.9. If I remember the form table of 49, 49, 98, 147, 196. So it's 3 and it's 4. So it's nothing but 3 by 4. And this 3 by 4 is 1 by n square minus 1 by n plus 1 whole square, which is only feasible when the transition is from 1 to 2. 1 by 1 square minus 1 by 2 square. It's 1 minus 1 by 4. That's 3 by 4. Right? So the value of n will be 1. So the value of n is 1. How many of you could solve it? Perfect. Very good. Yes, n is equals to 1 is the right answer. Shall we move ahead? Next question. Now we are done with the Bohr models. After completing Bohr model, generally we move to hydrogen spectrum. Yes. Now from here onwards, we'll be solving the question of hydrogen spectrum. Right? For the emission line of atomic hydrogen from Ni equals to 8 to Nf equals to n, the plot of wave number against 1 by n square will be. So now typical question of hydrogen spectrum, simply formula based. Can you solve it? Please try to solve it. Please solve it. Yes, Swami, n equals to 1. Perfect. So please solve it ASAP. I'm giving you 30 seconds. Shall we start? Simple formula based. What is wave number? Wave number is nothing but inverse of lambda, right? The number of wavelengths in a unit length, it is nothing but wave number. And this 1 by lambda is always equals to RH into Z square 1 by N1 square minus 1 upon N2 square. Can I say this wave number? This one. What is Ni here? Ni they have given as 8 and Nf they have given as N. So N1 is basically equals to 8, N2 is equals to N. Put it in the formula. RH into Z square, Z is 1 square only upon 1 minus 8 square minus 1 upon N square, right? So mu bar equals to RH upon 64 minus RH upon N square. If we plot a graph between wave number and 1 by N square, it is typically a straight line, right? Okay. So the graph will be somewhat like this. Wave number versus 1 by N square, and it is y equals to c minus mx. What's the slope here? 1 by N square coefficient. And this coefficient is nothing but RH, right? So the slope is tan theta equals to minus of, right? Is this clear, everyone? Linear with a slope of minus RH. Done? Shall we move ahead? Okay. Now, once again, a typical question or most frequent question which has been asked repeatedly in JEE paper. Whenever I say JEE paper, it means previous IT paper as well as in JEE mains paper. Such questions have been repeatedly asked. Lehman's lines, Balmer lines, and all these things. So a very, very important one for all the students, whether you are going to write your medical exam, your engineering entrance exam, or going to write next year entrance exams. So this particular question is really important. First of all, I'm going to give you 1 minute for this. Please try to solve, and then we'll start our discussion. One minute will be too much, right? 30 seconds. Done? Shall we start? For any given series of spectral lines of atomic hydrogen, let mu bar, again wave number, they are giving in terms of wave number. Mu bar equals to mu bar max minus mu bar min, with the difference between the maximum and the minimum frequency in centimeters. Anyhow, this unit is not going to work here. Ratio is there, so it will be a unitless, dimensionless quantity, right? The ratio of delta of mu Lehman upon del of mu Balmer. Perfect. Let's calculate this delta of mu Lyman. Lyman, I will write it as L, and which is nothing but max L minus V min L, right? What is this V bar? That's nothing but wave number 1 by lambda. I say this V bar is directly proportional to energy, because this V bar is nothing but 1 by lambda, right? And energy is also hc by lambda. So V bar directly proportional to energy. More is the energy gap, higher will be the magnitude of V bar, right? Now if I talk about Vmax Lyman, N1 has to be fixed, and N1 value is how much? 1. Now if I have to get the maximum energy, N2 has to be, energy will be max when this height is increasing continuously, right? And what will be the final value of N2? Infinity. N2 equals to infinity. Now can I calculate V bar? Let's try to calculate it. Vmax of Lyman equals to RH. Atomic hydrogen is there, so 1 square by 1 square minus 1 upon infinity square. Whereas Vmin of Lyman will be equals to RH z square, and this z is nothing but 1, so 1 square. Now minimum energy, so N1 has to be fixed, and the first step will be N2, and N2 value will be 2 only. I am moving from 1, our first step will be 2 only, right? So 1 upon 1 square minus 1 upon 2 square, and it is nothing but 3 RH by 4. Now I need to calculate del of this. So del of this is nothing but RH upon 4, right? This is for Lyman. Now in the same way, can I calculate for Balmer also? Yes. Balmer, visible spectra, right? So N1 is always equals to 2. Balmer. Now, if I need to calculate V bar max, energy has to be maximum. I'm moving from second step. It has to be maximum. So N2 has to be infinity. So the transition will occur from 2 to infinity. 1 upon 2 square minus 1 upon infinity square, which is nothing but RH by 4. Right? Now, V min of Balmer writing Balmer as B, right? So this is equals to RH into 1 square 1 upon 2 square, and 1 is always fixed in case of Balmer series, as it lies in a visible spectra, right? 1 upon 2 square, and the first step will be the third step only. So it's 1 upon 2 square minus 1 upon 3 square, 36, 9 minus 4. So it's 9 minus 4, 5 RH upon 36, right? Del of this mu bar max Balmer minus mu bar min Balmer. Can we calculate? RH by 4 minus RH by 36. 36 will be the LCM, and it's 9 minus 5, 4 RH upon 36. This is the difference. So here it's RH upon 9. First one, second one, and the first one is RH upon 4. Now I need to calculate the ratio. 1 divided by 2. Let me write here in this slide itself. This is nothing but RH by 4, and this is nothing but RH upon 9. If we divide it, it will go as 9:4 is the correct key. Am I clear, everyone? Is this clear to everyone? How many of you could solve it? A very important questions related to hydrogen spectra. Frequently asked question, or one of the most typical question which you may find either in JEE mains paper or in IIT's paper. Shall we move ahead? Now, so we are done with Bohr's model. We are done with hydrogen spectra. Moving ahead, the next question which is there on the screen is taken from de Broglie. So from here onwards, we'll start thinking electron, or we'll start taking electron as a standing wave, right? The question says the de Broglie wavelength associated with a photoelectron varies with frequency of the incident radiation H. Okay, so they have clubbed two concepts, one de Broglie and the other one photoelectric effect. And after clubbing these two concepts, this question is framed. A very typical questions asked in the JEE mains 2019 January attempt. Can you solve it? Can you solve it? Please. Okay. Siddharth Pandit Aryabhatta, whatever it is, Siddharth Pandit, Soumya, Satyam. Can you solve it? Everyone. De Broglie wavelength associated with a photoelectron A varies with the frequency mu of the incident radius. Perfect. So suppose a photometallic surface is there. On this photometallic surface, a photon is falling. Single photon will emit a single electron, right? And I need to calculate the de Broglie wavelength of this particular electron. I hope you got my question. A photon is incident on a photometallic surface. A single photon is emitting a single electron, and now I need to calculate the wavelength associated with this particular electron. Shall we start? Okay. So first apply energy conservation. I think they have given mu or mu naught and mu. Perfect. So work function and incident energy they have given. Can we apply this photoelectric equation? H nu incident energy equals to H nu naught plus KE max. And what is this KE max? Can we calculate from here? KE max equals to H nu minus H nu naught. Now I know the kinetic energy of the emitted electron. Now I need to calculate the wavelength associated with this particular electron. Is there a correlation between kinetic energy and wavelength? Yes. Lambda equals to h upon p. I hope you remember it. Right? Do you remember it? Tell me. And this p, what's the relation between momentum and kinetic energy? So this p square upon 2m is always equals to k. What is this p? Under root 2m dot k. Can I place it over here? Can I write it here itself? Lambda equals to h upon under root 2m dot k, and this k is nothing but h nu upon h nu naught. So h upon under root 2m into h common I can take mu minus naught. So this lambda is inversely proportional to mu minus mu naught e power 1 by 2. D is the correct answer. D is the correct key. I hope it's clear to everyone. Is this clear, everyone? Is this particular question clear? Do let me know. Siddharth D, Satyam D, Soumya D. Perfect. So shall we move ahead? Shall we move ahead? Okay. Now, the next question is related to magnetic moment. Do you remember what does it mean by this term magnetic moment? Somewhere you might have studied in atomic structure or periodic table. Through this, we tell the magnetic behavior of any substance, whether it's a paramagnetic or diamagnetic, will be attracted in a magnetic field or will get repelled in a magnetic field, right? So, what's the formula for this? Mu. It is represented by the symbol mu. This mu equals to under root of n into n plus 2 Bohr magneton. And what is this n? Number of unpaired electron. N is number of unpaired electron, right? Okay. Fe plus 3. Iron is in plus 3 oxidation state. Can you tell me the configuration of this iron plus 3? Iron plus 3 is nothing but argon 3d5, right? 26 minus 3, 23, 18 plus 5, 23. So argon 3d5, right? Now, so how many unpaired electrons? All the 5 electrons will be unpaired. So n equals to 5. And if n is 5, what will be the value of magnetic moment? 5 into 7, that's 35. Now, if I talk about this CO2 plus, CO2 plus 27, 27 minus 2, 25, argon 3d7, 3d7, 3d7 means how many unpaired electron? 5 filled, 6, 7, so 3 unpaired, n equals to 3, and mu value will be equals to under root 3 into 5, root 15, and for iron it's root 35. So what will be the ratio? Root 35 is to root 15 will be the correct key. B is the correct key, right? Siddharth, Satyam B, Sahil A. Sahil, please recheck your answer. Root 7 is to root 3. No, please check. Okay, shall we move ahead? Now, once again, a very typical question. This particular question was asked even in JEE, IIT, I can say as right now it's an advanced paper. It was asked in advanced paper in the year, way back in the year 2004. Again, it was asked in the year 2017, similar pattern, 2017, 2018, and then even in JEE mains. This particular question has been asked same thing. Even the data is also given the same. Can you solve it? A very important and a standard one. Very easy one, right? We need to calculate radial node. What is meant by the term radial node? What do we mean by the term radial node? Node, what is node? The region where the probability of finding the electron is 0. What do we mean by the term radial node? The distance where the radial probability of finding the electron is 0. And what is radial probability? What is wave function? What is radial wave function? What is radial probability? What is radial probability density? Can you tell me? So this psi of 2s equation they have given, it is representing, it's nothing but the wave function or amplitude function they have given. Wave function plus amplitude function they have given. Now it has got two components. One radial component in the polar coordinate and the other one is the angular component. So this psi of s is a function of r of r, theta of theta, and phi of phi. These are the zenith and azimuthal component, and this one is the radial component. They have not included the angular component, so they are simply saying they have given the equation of radial component, so they have given radial wave function equation. R of r they have given, this is nothing but radial wave function. Radial wave function. How the amplitude varies, or how amplitude varies with distance. Amplitude as a function of r. In Cartesian coordinate, it will be a function of x, y, and z. Right? Okay. Now, what is r square r? It is radial probability density. Density of finding electron at a point. Charge at a point is nothing but charge density. Probability of finding anything at a point, probability density. Right? Now, one more term. R square r into, since atom is considered to be spherical, so the difference between the two spherical volume will be 4 pi r square dr. This overall. Radial probability density into volume, density into volume, simply come out as radial probability. This will come out as radial probability. Now, if I have to calculate the radial node, always what you need to do, you need to make this term. So for radial node, this function has to be 0, and this function will only be 0. This one cannot be 0 at any cost because it's a constant, and this one will be 0 at r equals to infinity. So now this function will have a value of 0 only when, or even if I square it, it will have a value of 0 only when this function approaches to 0. So when 2 minus r upon a naught equals to 0, at this particular distance, our radial probability will be 0, and I will get a radial node. What's the value of r? It's 2a naught. B is the right key. Anyone? D. Perfect. Good, everyone. So, we are done with the questions of atomic structure. Now it's time to move to the next chapter, and now we are going to move again a very important chapter of chemistry, which is not only limited to chemistry but even in physics, the thermodynamic aspects of chemistry. We have just now discussed the atomic structure portion, the atomic modeling of electrons, right? Now it's time to discuss thermodynamics. Again, a very important chapter for chemistry as well as physics. 1 to 2 questions for sure it will be asked from chemistry, and 1 to 2 questions from physics. So sum total of 4 questions, right? Very typical, very easy, and a highly scoring chapter of chemistry. Shall we start? Yes. The first question which is there on the screen. For a diatomic ideal gas in a closed system, which of the following plots does not correctly describe the relation between the various thermodynamic quantities? Please try to solve it. Done. CP, CV, internal energy, CV versus V. Important parameters are given. I hope you remember each one of the important parameters, right? What is the CP and CV? CP. What is this CP? Molar heat capacity at constant pressure. Molar heat capacity at constant pressure, right? And how do we calculate it? It's in terms of degree of freedom is F by 2 plus 1 R, right? Similarly, what is CVM? It's F by 2, right? Basically, all these parameters I am trying to write in terms of degree of freedom will be used in this particular question. Now, internal energy for an ideal gas at a given temperature for n moles, it is F by 2 nRT, right? Now, use these three formula and try to solve this particular question. CP versus P straight line. P and CV value remains constant at a given pressure and at a given volume. At a constant pressure, this CP will remain constant. So the correct key will be, or the correct graph will be like this, right? The molar heat capacity at constant pressure. It has nothing to do with, CP does not vary with pressure at all. So this one is wrong. Second one, CV, temperature. CV remains constant at a given volume. But will CV vary with temperature? Can anyone tell me? Will CV vary with temperature? Sir, my shift is on 22nd, first shift. So should I do the remaining chapters that I have? No, now you should leave it because hardly 6 to 7 days are there. So revise all the previously or the chapters which you have studied so far. Now, everyone, please solve it. A. Okay, will CV vary with temperature? Tell me. How CV will vary with temperature? Can anyone tell me? How and why? This CV will vary with temperature. How and why this CV will vary with temperature? Yes, CV somewhat varies with temperature. Why? Because at higher temperature, at a given temperature, if the temperature is moderate or less, then well, this CV is nothing but F by 2, right? And this degree of freedom will be fixed, right? For monoatomic, it's 3. For diatomic, it's 5. For polyatomic, it may be 5 or 6 or something like that, right? But if the temperature varies, at a very high temperature, even the vibrational degree of freedom is also considered. So once the temperature is raised, again the value of degree of freedom will increase. And if degree of freedom will increase, CV value will increase. So this graph is correct. Now, internal energy, a direct function of temperature, U directly proportional to temperature. And again, as the temperature increases, the degree of freedom increases. So the graph will go like this. Am I clear? This CV remains constant at a given volume. So D is also correct. B, C, and D are the correct key. A is the wrong key. And they are asking wrong key only. Does not correctly describe. So A will be the right answer. Shall we move ahead? Moving to the next question. In a typical question taken from first law of thermodynamics, a very easy one. All the questions which we have discussed so far, relatively much easy. You can solve it, somewhat directly formula related. So please try to attempt it and solve it. 5 mole of an ideal gas at 100 Kelvin are allowed to undergo reversible compression till its temperature becomes 200 Kelvin. If CV equals to 28 joules per mole per Kelvin, calculate delta U and del of PV. Can anyone solve it? Anyone? Do it fast. Shall we start? Internal energy they are asking to calculate. The keyword is ideal gas. Monoatomic, diatomic, have they given? No, directly they have given the CV value. Perfect. And they are asking to calculate delta U. Delta U is nothing but N into CV into delta T, right? So N value they have given as 5, T value they have given as 28, and delta T value they have given as 100. 140, 100 to 100, right? Joules. 140 into 100 joules. In terms of kilojoules, I need to divide it by 1000. So it will come out as 14 kilojoules. So delta U magnitude will be 14 kilojoules. Now, delta of PV. How we calculate delta of PV? We have studied PV equals to nRT, right? N is constant, R is constant. So del of PV here will be nr. I can take it as constant. So nr del T. Delta of PV is nothing but nr del T. N they have given as 5. R I am taking at 8. Have they given it? 8, yes. 8 and del T is 100. So 40 into 100, 4000 divided by 1000 in terms of kilojoules. 40,000, yeah. So it's 4 kilojoule. Del of PV is 4 kilojoule and del of U is 14 kilojoule. Will be your right key. Yes, a monoatomic ideal gas undergoes a process in which the ratio of P to V at any instant is constant and is equals to 1. What is the molar heat capacity of the gas? Very important question. Typical one. BVI I can write. Very, very important question. Have been asked in JEE mains, JEE advanced. This particular question was even taken. This is representing IIT paper, that JEE advanced. 2006 3 marks question, it was there. Very important concept, may be asked anytime. So while doing this question, please be attentive and try to solve it ASAP. Siddharth Pandit A, Sahil, Delta H, Satyam, Satyam, how much you got? A monoatomic ideal gas undergoes a process in which the ratio of P to V at an instant is constant. P by V equals to 1, right? So the process will follow the equation PV raised to the power minus 1 equals to K, right? What's the value of X here? X equals to, it's a polyatomic process where X equals to minus 1.